about you, but computers are getting more and more resource heavy. Let's talk about it. Your computer probably has 16 gigabytes of RAM. Am I right? 5 years ago, that would have been considered absolutely overkill. Today, though, yeah, that's barely enough to run Chrome with more than 10 tabs open. I'm about to show you why the tech industry's obsession with more RAM and processing power is both completely unjustified and utterly ridiculous at the same time. What's up, everyone? Welcome back to the channel. I'm Olive Badger, and today we're diving into the RAM arms race that's been happening in the PC world. Hopefully by the end of this video, you'll understand exactly why your future-proof gaming rig from 2020 is already feeling sluggish and why the solution might be more expensive than you think. We're going to explore the legitimate reasons why modern PCs need more power, but more importantly, I'm going to show you why most of these demands are completely artificial and how the software industry has been gaslighting us into buying more expensive hardware. So go ahead and make sure to hit that subscribe button because we're about to get into some seriously eye-opening stuff. All right, so before we jump into the current madness, let's take a quick trip down memory lane. In 2010, most gaming PCs shipped with 4 gigabytes of RAM, and that was considered plenty. By 2015, 8 gigabytes became the sweet spot. Fast forward to 2020, and 16 gigabytes was the recommended standard, and now in 2025, we're seriously talking about 32 gigabytes as the new baseline, with some enthusiasts pushing 64 or even 128 gigabytes. This isn't just about RAM either. The average gaming CPU has gone from dual-core to quad-core to now requiring 8 or even 12 cores for optimal performance. Graphics cards have exploded in both performance and price, with high-end GPUs now costing more than entire computer systems used to cost. But here's what's really wild. The basic tasks we use computers for haven't fundamentally changed. We're still browsing the web, editing documents, playing games, and watching videos. So why do we need exponentially more power to do more or less the same things? Let's start with the obvious question. Do we actually need all this RAM? And honestly, the answer is a frustrating yes and no. First, let's talk about why more RAM is genuinely necessary. Modern applications are absolute disgusting memory hogs compared to what we used to run. Your web browser alone can easily consume 4 to 8 gigabytes of RAM if you're the type of person who keeps 30 tabs open. And let's be honest, who isn't? My husband, but I am. This isn't just about poor browsing habits. Modern websites are incredibly complex with multiple scripts, high-resolution images, auto-playing videos, and background processes all demanding memory. Gaming is another legitimate driver and probably the most obvious one. Modern AAA titles routinely recommend 32 gigabytes of RAM. Games like Microsoft Flight Simulator, Cyberpunk 2077, and the latest Call of Duty titles can easily use over 20 gigs when running at high settings. These games are rendering incredibly complex worlds with millions of polygons, advanced lighting systems, ray tracing, and massive open environments that need to be stored in memory for quick access. The jump to 4K and even 8K gaming has made this exponentially worse. Higher resolution textures require more memory to store. A single 4K texture might be 50 to 100 megabytes compared to maybe 5 to 10 for the same texture at 1080p. When you're dealing with massive open-world games that might have thousands of unique textures, this adds up quickly. Content creation is where the RAM demands get truly wild. Video editing in 4K or 8K resolution requires massive amounts of memory to handle uncompressed footage. A single minute of 8K video can be several gigabytes in size. Professional workflows involving multiple applications running simultaneously Think Photoshop, After Effects, and Premiere Pro all open at once can easily consume 64 gigabytes or more. 3D rendering and animation work 3D rendering and animation work is even worse. Modern 3D scenes with high poly models, complex materials, and advanced lighting can require enormous amounts of memory just to load into the software, let alone render. I've seen professional 3D artists working on projects that require 128 gigabytes of RAM just to open the scene file. Then there's the rise of AI and machine learning workloads. Local AI models, which are becoming increasingly popular for everything from image generation to memory to text processing, require substantial memory allocation. Running something like Stable Diffusion locally can demand 12 to 16 gigs just for the model itself. More advanced models can require 24 to 48 gigs or even more. Virtual machines and development work also contribute to this demand. Software developers often need to run multiple virtual machines simultaneously, each requiring their own allocation of system memory. A developer might be running Windows, Linux, and macOS virtual machines simultaneously, each needing 8 to 16 gigs of RAM. Now, here's where things get absolutely bonkers. While there are legitimate use cases for massive amounts of RAM, the reality is that most of this demand is artificial and completely unnecessary. Let's start with the elephant in the room: software bloat. We're living in an era where a simple text editor can consume 200 megabytes of RAM. For context, that's more memory than an entire operating system used to require. The original iPhone, which revolutionized mobile computing, had 128 megabytes of RAM. Today's text editors use more memory than that iPhone's entire system. Web browsers are the worst offenders. They deserve special attention because they're probably the most used application on most people's computers. Modern browsers have become operating systems within operating systems. Each tab runs its own process, loads its own copy of various libraries, and keeps everything in memory just in case you might need it. The result? Opening 10 tabs can consume more RAM than running multiple professional applications used to require. Here's what's really infuriating. Most of this memory usage provides zero benefit to the user. Your browser doesn't run faster with 16 gigabytes of RAM versus 8 if you're doing just typical web browsing. The extra memory is just being wasted on redundant processes and cache data that will never be accessed. Here's a perfect example of how ridiculous this has become. Microsoft Excel, a spreadsheet application, now recommends 32 gigs of RAM for optimal performance. We're talking about a program that calculates numbers and displays them in cells. The original VisiCalc, which did essentially the same thing, ran on computers with 32 kilobytes of RAM. That's not a typo. Kilobytes, not gigs. We're using literally 1 million times more memory to accomplish the same basic task. The gaming industry is particularly guilty of this lazy optimization. Many modern games that demand 32 gigs of RAM aren't actually using that memory efficiently. They're often just poor ports from console versions, or they're loading unnecessarily high-resolution textures that most players will never notice. Some games literally load gigabytes of audio files into memory that could be streamed from storage with zero performance impact. I've seen games that use 20 gigs of RAM and still stutter during gameplay because they're poorly optimized. Meanwhile, games from 10 years ago that were masterfully optimized can run smoothly on a fraction of the memory and still look great. The most infuriating part: much of this bloat provides zero benefits to the users. Your productivity applications don't make you more productive just because they're consuming more resources. In many cases, the opposite is true. Bloated applications are slower and less responsive than their lightweight alternatives. I mean, have you noticed that? Because I definitely have noticed that. All right, so we need to talk about Electron applications because they are single-handedly responsible for a huge portion of modern RAM consumption, and most people don't even know what they are. So for those of you who don't know, Electron is a framework that allows developers to build desktop applications using web technologies like HTML, CSS, and JavaScript. Sounds pretty convenient, right? The problem is that each Electron application is essentially running its own copy of the Chrome browser. Let me give you some examples. Discord, Slack, WhatsApp Desktop, Spotify, Visual Studio Code, Figma, and dozens of other popular applications are all built using Electron. Each one of these applications is running a complete browser engine just to display what could be a simple interface. This means if you have Discord, Slack, and Spotify open simultaneously, you're running 3 separate instances of the worst browser, Chrome, each consuming at minimum 200 to 500 megabytes of RAM just to display chat messages and play music. It's like having 3 people driving separate cars to the same destination instead of carpooling. And the absurdity doesn't stop there. These Electron applications often use more memory than much more complex native applications. Discord chat application regularly uses more RAM than advanced video editing software. Spotify, which is essentially just a music player, can consume more memory than professional audio production suites. Here's what's particularly galling about this. Developers choose Electron not because it provides a better user experience, but because it's easier for them to develop. They can write one code base that works on Windows, Mac, and Linux instead of writing native applications for each platform. The cost of this convenience is passed directly to users in the form of higher hardware requirements. I don't blame the developers. I do think we need better tools. And the performance impact goes beyond just RAM usage. Electron applications are notoriously slower than native applications. They take longer to start up, they're less responsive, and they consume more CPU power. You're literally getting a worse experience while using more of your system resources. The same insanity applies to processing power, and in some ways it's even worse than the RAM situation. Modern CPUs are incredibly powerful, yet somehow everything feels slower than it should be. We have processors that can execute billions of calculations per second, but it still takes 3 seconds to open a text file. This is because software complexity has grown exponentially faster than hardware capabilities. We're asking our computers to run multiple layers of abstraction, frameworks, and unnecessary background processes. Your simple note-taking application might be running on top of a JavaScript engine inside an Electron wrapper using a React framework calling various APIs, all just to display text on a screen. The result being that we need increasingly powerful processors, not because we're doing more complex tasks, but because we're doing simple tasks in incredibly inefficient ways. It's like needing a Formula race car to drive to the grocery store because the roads are covered in molasses. Let me give you a concrete example. Modern smartphones, which have relatively weak processors compared to desktop CPUs. They can run incredibly smooth and responsive applications. Why? Because mobile developers are forced to optimize for limited resources. When you only have 4 to 8 gigs of RAM and a battery-powered processor, you can't afford to be wasteful. Now, the phones are getting worse, but not nearly as bad. Because meanwhile, desktop developers have gotten lazy because they assume users will just buy more powerful hardware. Why spend time optimizing when you can just put 32 gigs of RAM recommended on the system requirements? This has created a vicious cycle. Software gets more bloated, which requires more powerful hardware, which gives developers even more resources to waste, which leads to even more bloated software. We're trapped in this endless loop of inefficiency. The most frustrating part, at least for me, is that we actually have historical proof that this isn't necessary. Look at video game consoles. The PlayStation 5 and Xbox Series run incredibly demanding games on hardware that could be considered mid-range by PC standards. Why? Because console developers are forced to optimize for for fixed hardware specifications, much like mobile phones. The artificial demand for RAM and processing power has real economic consequences that go far beyond just your wallet. The average gaming PC build has gone from $800 to $1,000 to $1,500 to $2,000 in just a few years, largely due to memory and processor requirements. That's not because the hardware is more expensive to manufacture, it's because software demands have artificially inflated the baseline requirements. But the economic impact goes deeper than just higher prices. The constant need for upgrades has created a culture of planned obsolescence in the PC world. Perfectly capable computers are being discarded as obsolete when they could easily handle modern tasks if software was written efficiently. For example, I have an old laptop. Nothing wrong with that laptop, it just can't run Windows anymore, so I loaded Ubuntu on it, thing is good to go. The environmental impact is staggering. We're creating massive amounts of electronic waste, not because the hardware is failing, but because the system is poorly optimized. Think about all the perfectly functional computers sitting in landfills because they don't have enough RAM to run modern bloated applications. From a manufacturing perspective, the demand for more RAM and processing power is driving up the cost and complexity of chip production. This has geopolitical implications as well, as countries compete for semiconductor manufacturing capabilities to meet these artificially inflated demands. So, what's the solution? Unfortunately, there isn't an easy one. As consumers, we're trapped in this cycle where we need to buy more powerful hardware to run increasingly bloated software. But there are a few things you can do. First, as always, vote with your wallet. Support developers and companies that prioritize efficiency over feature bloat if you can. Choose lightweight alternatives when possible and use native applications instead of web-based ones when possible. For example, use the native email client instead of running Gmail in a browser tab. Don't automatically upgrade just because new hardware is available. That 16 gig of RAM you have might be perfectly adequate for your actual needs, regardless of what the system requirements say. Test your actual usage patterns before deciding you need more memory. Be aware of what's actually consuming your system's resources. Use Task Manager or Activity Manager or benchmarking tools to identify the worst offenders and consider alternatives. You might be surprised to find that a simple chat application is using way more resources than your video editing software. And finally, we need to start holding software developers accountable. When a simple application demands excessive system resources, call it out. Write reviews, make noise. The only way this cycle breaks is if there are consequences for poor optimization. And keep in mind, the software devs, it's not entirely their fault. This really is a business decision. The truth is, we're living through one of the most powerful but wasteful periods in computing history. We have more powerful hardware than ever before, yet somehow need even more powerful hardware to accomplish the same basic tasks we were doing a decade ago. It's both completely necessary because software demands it, and completely ridiculous because those demands are largely artificial. So until the software industry starts prioritizing efficiency over convenience, we're stuck in this expensive arms race of buying more RAM and processing power to run increasingly bloated applications. The irony is that we could probably run most modern software on hardware from 5 years ago if developers actually cared about optimization. Instead, we're told to upgrade our hardware every few years to keep up with software that isn't actually doing anything more useful than what we had before. But what do you think? Are you tired of upgrading your PC every few years just to keep up with software demands? Have you noticed the bloat in your favorite applications? Let me know in the comments below, and don't forget to subscribe for more videos and like if you enjoyed this one. Anyway, that's all I've got for you today. Thank you so much for watching this video. I hope you have a fantastic rest of your day, and peace out. Bye.